In the vastness of the cosmos, there must be other civilizations far older and more advanced than ours. So shouldn't we have been visited? Shouldn't there be every now and then alien ships in the skies of Earth? There's nothing impossible in this idea, and no one would be happier than me if we were being visited. But has it happened in fact? What counts is not what sounds plausible, not what we'd like to believe, not what one or two witnesses claim, but only what is supported by hard evidence, rigorously and skeptically examined. Extraordinary claims require extraordinary evidence. Since 1947, there have been hundreds of thousands of reports of UFOs, unidentified flying objects. This subject has more, I think, to do with religion and superstition than with science. Let's consider one of the most famous accounts of a supposed encounter with alien beings. On September 19th, 1961, an American couple were driving home through New Hampshire.
What's the matter, Delcy?
They were returning along a lonely road late at night from a vacation in Canada. Remember, we have only their word for what happened next.
I can't get anything but a scatter. You still don't believe it, do you?
No, I don't. There must be a reasonable explanation.
They had observed, so they said, a strange moving light in the sky. By definition, an unidentified flying object. It seemed to follow them for miles.
What's the matter with that dog?
What's that sound?
I don't know.
After a time, the lighting patterns on the UFO changed. It appeared to land. It blocked the road, preventing them from driving on. They said they saw mouthless creatures approaching who were not exactly human.
Barney? Barney? Barney, what is that?
At this point, the story becomes still stranger. They lost all recollection of what happened in the next few hours. But weeks later, they said, they recalled some details and discussed the experience with others. 26 months later, under hypnosis, they reported that a UFO had landed and that the crew had emerged. They were captured, they said, and taken aboard the craft. That was the story told by Betty and Barney Hill. Virtually all scientists who've studied it are skeptical. But UFO enthusiasts think the Hill case is a classic example of a close encounter of the third kind. Why? What makes it so special? While on board, Betty had noticed a book written in an unknown hieroglyphic writing. She was also shown a strange window through which she could see a glowing pattern of dots connected with lines. It was, they told her, a star map, displaying the routes of interstellar commerce. Afterwards, the Hills were released and permitted to return home, or at least this is their story. Now, believers find this account compelling, or at least plausible, chiefly because of the alleged star map. Here's what Betty Hill said it looked like. Now, why would anybody take this seriously? Because here is a real map widely publicized by UFO enthusiasts, of 15 selected nearby stars, including the sun, as seen from one particular vantage point in space. This map includes stars that were first cataloged several years after Betty Hill recalled what she says she saw in the alien ship. Her map required, we are told, information that was not then available on the Earth. There is a resemblance between the two maps, but that's mainly because the lines corresponding to navigation routes have been copied from the Hill map onto the real star map. If we were to substitute some other set of lines for the Hill lines, we find that the eye suddenly is biased against seeing any agreement between the two maps at all. To make an objective test, however, let's remove the lines altogether. And then there's very little resemblance left. But these particular stars are selected from a large catalog of star positions. Our vantage point in space is also selected to make the best possible fit with the Hill map. If you can pick and choose from a large number of stars, viewed from any vantage point in space you want, you can always find something resembling the pattern you're looking for. I'm surprised that nobody could find a better fit to the Hill map. The Hills' own psychiatrists described their story as a kind of dream. There's no corroborating evidence. The star map argument is worthless. And yet, this is one of the best attested cases of UFO close encounters. For all I know, we may be visited by a different extraterrestrial civilization every second Tuesday. But there's no support for this appealing idea. The extraordinary claims are not supported by extraordinary evidence.
There are curious daylight photos of UFOs. Some look suspiciously like hats or hubcaps thrown into the air. Photos can be faked. More common are unidentified lights at night. They're often aircraft, but if we can't identify a light, that doesn't make it a spaceship. Here's a movie of what you might think is a UFO. Actually, it's a piece of an asteroid burning up as it enters the Earth's atmosphere.
Most reports of unidentified flying objects turn out to be something else, like the refracted image of a bright planet or the re-entry of an artificial satellite. Some are psychological aberrations, some are hoaxes. Never is there any compelling physical evidence, a detailed close-up photograph of a strange spacecraft or a small device of extraterrestrial manufacture, or a book written in alien hieroglyphics. Never. There are reports of such things, but never the things themselves.
The search for alien civilizations retains its importance despite the striking failure of the UFO evidence. Most astronomers, for example, consider extraterrestrial life a subject worthy of vigorous, if cautious, pursuit. For myself, I find something irresistible in the idea of discovering a token, maybe a simple inscription, which would provide the key to understanding an alien and exotic civilization. This is an appeal we humans have felt before. In 1801, a famous physicist was the governor of the French province of Isère. His name was Joseph Fourier. On a routine inspection of the schools in his province, Fourier discovered an exceptional 11-year-old boy, Jean-François Champollion. The boy's precocious intellect and remarkable flair for languages had already earned him the admiring attention of local scholars. Fourier, too, was impressed. What Champollion first saw in Fourier's house determined the course of his life and unlocked the secrets of an alien civilization. Fourier had recently participated, as one of many scientists, in Napoleon's expedition to the Middle East. He had been in charge of cataloging the astronomical monuments of Egypt. The boy was entranced by Fourier's collection of ancient Egyptian artifacts, the mysterious fragments of a lost world. France at this time was flooded with such artifacts, plundered by Napoleon, and now arousing intense interest among scholars and the general public. The boy's attention was caught by a specimen of Egyptian hieroglyphics. "What do they mean?" he asked. "Nobody knows," was Fourier's reply. Then and there, Champollion resolved that he would understand this language that no one could read, that he would decode the messages from another world and another time. He became a superb linguist and immersed himself in the hieroglyphics. Fourier edited the illustrated description of Napoleon's expedition. The young Champollion studied it hungrily. To the people of Europe, these exotic images revealed an utterly alien civilization, a world of towering monuments and magical names: Dendera, Karnak, Luxor. Every illustration was a riddle posed by the past to the present. And among them were pictures of something called the Rosetta Stone, and portraits of the people who lived among the ruins of the pharaohs. Egypt became the land of Champollion's dreams. But it was not until 1828, 27 years after his fateful visit with Fourier, that Champollion first set foot in Egypt. With his companions, Champollion chartered boats in Cairo and sailed slowly upstream, following the course of the Nile. It was a journey of many weeks, which Champollion recorded in extraordinary detail. This was an expedition through time, a voyage across the centuries to another world. Champollion, as an adult, had already worked out a brilliant decipherment of the hieroglyphics, a word, incidentally, that means sacred carvings. Now Champollion was making a pilgrimage to the scene of the ancient mysteries he had been the first to understand. Champollion wrote, "The evening of the 16th, we finally arrived at Dendera. We were only an hour away from the temples, could we resist the temptation? I ask the coldest of you mortals. To dine and leave immediately were the orders of the moment. Alone and without guides, we crossed the fields. Presuming that the temples were in a straight line from our boat, we walked thus for an hour and a half without finding anything. We finally discovered a man who put us on the correct route and ended up walking with us with good graces. The temple appeared to us at last. I shall not try to describe the impression which the porches and above all the portico made on us. We stayed there 2 hours in ecstasy, running through the huge rooms and trying to read the exterior inscriptions in the moonlight. It was with no small rapture that Champollion entered the secret places of the temple and scanned the words that had waited patiently through 500,000 nights for a reader. To his brother, Champollion wrote of his joy in confirming that he could understand the writing on these walls. I am now proud, he said, that having followed the course of the Nile to the Second Cataract, I have the right to announce that there is nothing to modify in our letter on the alphabet of hieroglyphics. Our alphabet is good. It is applicable with the same success, first of all, in Egyptian monuments of the epoch of the Romans, and also, which is more interesting, to the inscriptions on all temples, palaces, and tombs of the pharaonic epoch. Champollion was overwhelmed by the grandeur which surrounded him. It is the union, he said, of grace and majesty in the highest degree. We in Europe are only dwarfs. No nation, ancient or modern, has conceived the art of architecture on such a sublime, great, and imposing style as the ancient Egyptians. They ordered everything to be done for people who are 100 feet high. This is the great temple of Karnak in Upper Egypt, continuously constructed over a period of more than 2,000 years, until the time of the Ptolemies. It was here, Champollion wrote, that all the pharaonic magnificence appeared to me. What he had seen elsewhere, he said, seemed to me miserable compared with the colossal conceptions around me. On these walls and columns at Karnak, at Dendera, and everywhere else in Egypt, Champollion found that he could read the inscriptions, that his decipherment of a few years earlier had been correct. But how had he figured it out? Many had tried and failed to read the hieroglyphics. One group of scholars thought they were a kind of picture code full of murky metaphors, mostly about eyeballs and wavy lines and animals. Birds, especially birds, lots of birds. There were those who deduced from the hieroglyphics that the Egyptians had been colonists from China. There were those who deduced it the other way around.
There was one character who, from a single look at the Rosetta Stone, deduced its meaning. He said that the quickness of his decipherment enabled him to avoid the systematic errors which invariably arise from prolonged reflection. You get better results, he was saying, if you don't think about it too much. As in the search for extraterrestrial intelligence today, the unbridled speculation by amateurs served to frighten many professionals right out of the field. Champollion was not frightened. He was also not distracted by the idea of hieroglyphs as pictorial metaphors. Instead, using the insights of a brilliant English physicist named Thomas Young, he proceeded something like this. This is an exact replica of the Rosetta Stone. The original had been found in the year 1799 by a French soldier working on the fortifications of the Nile Delta town of Rashid, which the Europeans, in their persistence not to learn Arabic, called Rosetta. It had been part of an ancient temple which had been torn down. If we look at it, we see that it clearly represents the same text in 3 different languages. Up at the top, ancient Egyptian hieroglyphics. In the middle, a kind of cursive and later hieroglyphic called Demotic. And down at the bottom, the key to the enterprise, Greek. Champollion could, of course, read ancient Greek. He was a superb linguist, and discovered that this stone had been inscribed to commemorate the coronation of King Ptolemy V Epiphanes in the spring of the year 196 BC. As we would expect, the Greek text includes many references to King Ptolemy. Here, for example, you can see it. Ptolemeos. Now, in roughly the same positions, but in the hieroglyphic text, are these ovals, or cartouches, as they're called. And if this cartouche really means Ptolemy, then the individual hieroglyphs are unlikely to be pictograms or metaphors. Much more likely they're letters, or at least syllables. In addition, Champollion had the presence of mind to count up the number of Greek words and the number of individual hieroglyphics in what are presumably equivalent texts. He found that the number of individual hieroglyphs is much larger than the number of Greek words, again implying that the hieroglyphs are mainly letters and syllables. But which hieroglyphs correspond to which letters? Fortunately, Champollion had available to him a kind of second Rosetta Stone, an obelisk which had been excavated at the Temple of Philae, and which had inscribed upon it cartouches representing the hieroglyphic equivalent of another Greek name, Cleopatra. So here we have the Cleopatra cartouche, and here's the Ptolemeus cartouche. Here we've turned it around, changing left to right to left, and spread the hieroglyphs out so we can see them all. Now, immediately we notice that there are some similarities. This first hieroglyph in Ptolemy is a kind of square. The 5th hieroglyph in Cleopatra is a square, but Cleopatra, both of them seem to represent a P. So Ptolemy and Cleopatra both give us the same interpretation. A square is a P. Likewise, the 4th hieroglyph in Ptolemy is a lion. Tol, P-T-O-L. Likewise, the 2nd hieroglyph in Cleopatra is an L. So again, it's consistent. The pattern is emerging. Likewise, this rope or hangman's noose, Ptolemy, it's an O. Cleopatra, it's an O. And in this way, Champollion was able to assign letters for each of the hieroglyphs we see here. Ptolemeus, and likewise Cleopatra. tra. The eagle is an A. You notice there are two different symbols for T, but in English, same sort of thing, F and PH. Champollion discovered that the hieroglyphics were basically a simple substitution cipher. Now, there's other stuff in here. All the rest of this in the cartouche, what's that about? Well, he was later able to find out. This is a symbol called the Ankh, which means life. Here, there's a PT, that's a Ch, makes Ptach, name of a god. And the whole cartouche read, Ptolemy, ever living, beloved of the god Ptah. Likewise, the end of the Cleopatra is a short form meaning daughter of Isis. So it turns out that Champollion's opponents were not wholly wrong. Some of the hieroglyphs, for example, the symbol Ankh, which means life, are ideograms or pictograms, but the key to the enterprise, Champollion's success, rested on his realization that the hieroglyphs were essentially letters and syllables. In retrospect, it sounds almost easy, but it took people hundreds of years before they figured it out. Champollion walked these halls and casually read the inscriptions which had mystified everybody else, answering the question he had posed as a child to Fourier. What do they mean? What a joy it must have been for him to open this one-way communications channel with another civilization, to permit a culture which had been mute for millennia to speak of its history, magic, medicine, religion, politics, philosophy. Today, we also are seeking messages from an ancient and exotic civilization, a civilization hidden from us not in time, but in space.
Today, we are searching for a message from the stars. We have not found it so far. We have as yet no Champollion. But we are just beginning. Perhaps those who will discover and decipher the first interstellar communications are alive at this moment, somewhere on the planet Earth. Extraterrestrial beings will have a different biology, a different culture, a different language. How could we possibly understand their messages? Is there in any sense a cosmic Rosetta Stone? I believe there is. All the technical civilizations in the cosmos, no matter how different they are, must have one language in common, the language called science. The laws of nature are everywhere the same. Every chemical element has a specific signature in the spectrum. So there are identical patterns in the light of a candle flame on Earth and in the light of a distant galaxy. The spectra show not only that the same chemical elements exist throughout the universe, but also that the same laws of quantum mechanics govern atoms everywhere. Beings growing up on any world must come to grips with the identical laws of nature. Galaxies billions of light years distant evolve a spiral form. So does our own Milky Way. The same gravitational forces are at work. And on planets also. There are spiral storm systems on Jupiter. The same patterns are common on Earth. The intelligent beings on every world will sooner or later understand the laws of nature. Someday, perhaps soon, a message from the depths of space may arrive on our small world. If we wish to understand it, we first have to understand science. We do not expect an advanced technical civilization on any other planet of our solar system. If they were only a little behind us, 10,000 years, say, they would have no advanced technology at all. And if they were only a little ahead of us, we who are already exploring the solar system, then they should be here by now. To communicate with other civilizations, our technology must reach across not merely interplanetary distances, but interstellar distances. Ideally, the method should be inexpensive, so that a huge amount of information could be sent and received at very little cost. It should be fast, so an interstellar dialogue is eventually possible. It ought to be obvious, so that any technical civilization, no matter what its evolutionary path, will discover it early. Surprisingly, there is such a method. It's called radio astronomy. This is the largest radio radar telescope on the planet Earth, the Arecibo Observatory. It's located in a remote valley on the island of Puerto Rico. It sends and receives radio signals, but it's so large and powerful that it could communicate with an identical radio telescope 15,000 light years away, halfway to the center of the Milky Way galaxy. The Arecibo Observatory has been used, although sparingly, to search for signals from civilizations in space, and just once, to broadcast a message to a distant star cluster called M13. But is there anyone out there to talk to? With 400 billion stars in the Milky Way galaxy alone, could ours be the only one with an inhabited planet? How much more likely it is that the galaxy is throbbing and humming with advanced societies. Perhaps near one of those pinpoints of light in our night sky, someone quite different from us is glancing idly at the star we call the sun and entertaining just for a moment an outrageous speculation. There are an enormous number of stars. Only some of them will have planets suitable for life. On only some of those worlds will intelligence arise. And perhaps a few of those civilizations will avoid the trap jointly set by their technology and their passions. If there are many civilizations, one of them should be rather close by. If there are few civilizations, then even the nearest may be very far away. This is one of the great questions. How many advanced civilizations capable, at least of radio astronomy, are there in the Milky Way galaxy? Let's call the number of such civilizations by the capital letter N. It's a number. It depends on many things. It depends on the total number of stars in the Milky Way. Let's call that N sub star. It depends on the fraction of stars that have planets. Let's call that F sub P. It depends on the average number of planets in a given solar system that are ecologically suitable for life. Let's call that N sub E. It depends on the fraction of suitable planets in which life actually arises. Call that F sub L. It depends on the fraction of inhabited planets on which intelligence emerges. Let's call that F sub I. And on the fraction of those planets in which the intelligent beings evolve a technical, communicative civilization, call that F sub C. Finally, it depends on the fraction of a planet's lifetime that's graced by a technical civilization, call that F sub L. If we multiply all these numbers together, we've estimated capital N, the number of civilizations. This equation, due mainly to Frank Drake of Cornell, is only a sentence. The verb is equals. So let's try to go through the program of this equation. By carefully counting the number of stars in small but representative regions of the sky, we find that the total number of stars in the Milky Way is about 400 billion. It's a lot of stars. What about planets? Well, in studies of double stars, in investigations of the motions of nearby stars, and in many theoretical studies, we get a strong hint that many, perhaps even most stars, are accompanied by planets. So let's take f sub p, the fraction of stars that have planets, as a quarter. Then the total number of planetary systems in the galaxy is 400 billion times a quarter, or 100 billion. We'll write down our running totals in red. Now, if each system were to have, say, 10 planets, as ours does, there would be 100 billion times 10, or 1 trillion worlds in the galaxy, a vast arena for the cosmic drama. In our own solar system, there are several bodies that might be suitable for life of some sort. There's the Earth, of course, but there are possibilities for Mars, for Titan, perhaps for Jupiter. If other systems are similar, there may be many suitable worlds per system, but to be conservative, let's choose n sub e equal 2. 2 worlds suitable for life per system. Then the number of planets in the galaxy that is suitable for life would be 100 billion times 2, or 200 billion. Now, what about life? Under very general cosmic conditions, the molecules of life are readily made. They spontaneously self-assemble. It's conceivable that there might be some impediment, like some difficulty in the origin of the genetic code, say, although I think that's very unlikely given billions of years for evolution. On the Earth, life arose very fast after the planet was formed. So let's choose f sub L, the fraction of suitable worlds in which life does arise, as a half. In that case, the total number of planets in the Milky Way in which life has arisen once is 100 billion times 2 times a half, or again, 100 billion. 100 billion inhabited worlds. Now, the estimates get tougher. Many individually unlikely events had to occur for our species and our technology to emerge. On the other hand, there might be many different roads to high technology. Some scientists think that the path from trilobites to radio telescopes, or the equivalent, goes like a shot in all planetary systems. Other scientists disagree. Let's take some middle ground and choose f sub I as a tenth and f sub c as also a tenth, meaning that only 1%, a tenth times a tenth, of inhabited planets eventually produce a technical civilization. If we were to multiply all these factors together, we would find 100 billion times a tenth, or 1 billion planets on which civilizations have arisen at least once. Now, what percentage of the lifetime of a planet is marked by a technical civilization? The Earth has harbored a civilization capable of radio astronomy only for a few decades, the last few decades, out of a lifetime of a few billion years. It's hardly out of the question that we might destroy ourselves tomorrow. If that's a typical case, then f sub big L would be a few decades divided by a few billion years, or 100 millionth, a very small number. And then big N would be 1 billion times 100 millionth, or N maybe just 10 civilizations, a tiny smattering, a pitiful few technological civilizations in the galaxy. But civilizations then might take billions of years of tortuous evolution to arise and then snuff themselves out in an instant of unforgivable neglect. If this is a typical case, there may be few others, maybe nobody else at all, for us to talk to. But consider the alternative, that occasionally civilizations learn to live with high technology and survive for geological or stellar evolutionary timescales. If only 1% of civilizations can survive technological adolescence, then F sub big L would be not 100 millionth, but only 100th. And then the number of civilizations would be 1 billion times 100th. The number of civilizations in the galaxy then would be measured in the millions. Millions of technical civilizations. So, if civilizations do not always destroy themselves shortly after discovering radio astronomy, then the sky may be softly humming with messages from the stars, with signals from civilizations enormously older and wiser than we. If there are millions of technical civilizations in the Milky Way, each capable of radio astronomy, how far away is the nearest one? If they're distributed more or less randomly through space, then the nearest one will be some 200 light years away. But within 200 light years, there are hundreds of thousands of stars. To find the needle in this haystack requires a dedicated and systematic search. There are many cosmic radio sources having nothing to do with intelligent life. So how would we know that we were receiving a message? The transmitting civilization could make it very easy for us if they wished. Imagine we're in the course of a systematic search, or in the midst of some more conventional radio observations. And suppose one day we find a strong signal slowly emerging, not just some background hiss, but a methodical series of pulses. The numbers 1, 2, 3, 5, 7, 11, 13, a signal made of prime numbers, numbers divisible only by 1 and themselves. There is no natural astrophysical process that generates prime numbers. We would have to conclude that someone fond of elementary mathematics was saying hello. This would be no more than a beacon to attract our attention. The main message will be subtler, more hidden, far richer. We may have to work hard to find it. But the beacon signal alone would be profoundly significant. It would mean that someone has learned to survive technological adolescence, that self-destruction is not inevitable, that we also may have a future. Such knowledge, it seems to me, might be worth a great price. Very likely, some new Champollion would go on to decode the main message, using our interstellar Rosetta Stone, the common language of science and mathematics. Think of the glories of an exotic civilization far more advanced than we, collected by the great radio telescopes of Earth. Perhaps they would send a compilation of the knowledge of 1 million inhabited worlds, the Encyclopedia Galactica. The receipt of an interstellar message would be one of the major events in human history and the beginning of the deprovincialization of our planet. A serious and systematic radio search for extraterrestrial civilizations may come soon. preliminary steps are being taken both in the United States and in the Soviet Union. It's comparatively inexpensive. A search taking decades would cost less than the budget overruns on a single modest weapons system in a single year. Our technology is now fully adequate for this great challenge, but no systematic search program has ever been approved by any nation on Earth. When will we decide to search for what other civilizations there may be in the vast cosmic ocean? But whether there are only a few advanced galactic civilizations or millions, shouldn't some of them have voyaged to Earth?
On the one hand, we've argued that if even a small fraction of technical civilizations learn to live with themselves and their potential for self-destruction, then there should by now be enormous numbers of them in the galaxy. On the other hand, despite claims about UFOs and ancient astronauts, there's no credible evidence that the Earth has been visited, now or ever. But isn't this a contradiction? If the nearest civilization is, say, 200 light years away, it would take them only 200 years to get from there to here at the speed of light. Even if they were traveling 1,000 times slower than that, beings from a nearby civilization could have come here during the tenure of human beings on the Earth. So why aren't they here? There's many possible answers. One is that maybe we're the first. Some technical civilization has to be first to emerge in the history of the galaxy. Or maybe all technical civilizations promptly destroy themselves. That seems to me very unlikely. Or maybe there's some problem with interstellar spaceflight that we've been too dumb to figure out. Or maybe they are here, but in hiding because of some ethic of non-interference with emerging civilizations. We might imagine them curious and dispassionate, watching us to determine whether this year again we manage to avoid self-destruction. But there's another explanation which is consistent with everything else we know, and that's that it's a big cosmos. If a great many years ago an advanced interstellar spacefaring civilization emerged 200 light years away, why would they come here? They would have no reason to think there was something special about the Earth. There are no signs of human technology, not even our radio transmissions, which have had time to go 200 light years. From their point of view, all nearby planetary systems might seem equally attractive for exploration.
How would an interstellar civilization set out to explore its neighboring star systems? It might establish staging posts, colonies, on planets of nearby stars. But this would take time. Time to find and modify favorable planets, time to build new spacecraft. Eventually, later generations of explorers would set out, wending their way among the worlds, creating an interstellar nervous system, binding up the stars. Perhaps they would come upon another expanding civilization and encounter beings previously known only from their radio transmissions. Star wars are unlikely. One civilization almost certainly would be far more advanced than the other. It would be no contest. Perhaps they would cooperate, exploring together a small province of the Milky Way. But even nearby civilizations could spend millions of years roving between the stars without ever stumbling upon our obscure solar system. In a galaxy of 400 billion suns, perhaps no one has found us just yet. But advanced interstellar civilizations would know about many worlds, some inhabited, some barren. Perhaps they would share their findings, assembling some vast repository of the knowledge of countless worlds. They might compile an Encyclopedia Galactica. Suppose we could browse through that encyclopedia. We would choose some nearby province of the galaxy, a region that's fairly well explored, and then slowly leaf through the worlds. The young Champollion was inspired by reading Fourier's description of Egypt. Imagine the impact on us if we could study a rich compilation of not merely one world, but billions. Just possibly, not too far from our solar system, we might find a planet with a technical civilization only a little more advanced than we. Let's look them up in the Galactic Encyclopedia. What would a civilization far more advanced than ours be up to? Elsewhere, there may be engineering on a scale that dwarfs our proudest achievements. There may be cultures that disassemble other planets in their system and reassemble them around their world to make a ring or a shell with their planet inside. Imagine the energy crisis of a really advanced planetary civilization. They've used up all their fuels, they depend on solar power, but their growth is still severely limited by the energy available. An enormous amount of energy is generated by the local star, but most of the star's light doesn't fall on their planet. So perhaps they would build a shell to surround their star and harvest every photon of sunlight. Such beings, such civilizations, would bear little resemblance to anything we know. Perhaps someday there will be an entry in the Encyclopedia Galactica for our planet. Or perhaps even now there exists somewhere a planetary dossier garnered from our television broadcasts or from some discrete survey mission. They might summon up the index of blue worlds in our province of the Milky Way until they came to the listing for Earth. What would they know about us? What would they think of us? We have always watched the stars and mused about whether there are other beings who think and wonder. In a cosmic setting vast and old beyond ordinary human understanding, we are a little lonely. In the deepest sense, the search for extraterrestrial intelligence is a search for who we are. Since Cosmos was first released, interest in UFOs has persisted. It seems to me that there are fewer sightings of strange objects in the skies these days, and more stories about personal encounters with alleged extraterrestrials, like the account of Betty and Barney Hill that we dramatized. There are still people who claim to have been abducted by aliens, or even sexually abused, or even impregnated by them. Best-selling, purportedly serious books have been written about such claims. But the critical fact remains that all we have still is just anecdote. There are no close-up photographs, no artifacts, nothing that would convince a skeptic. All there are is stories. And stories just aren't good enough on a matter of this importance. I'm still waiting for hard evidence. The radio's search for extraterrestrial intelligence has been picking up. In Harvard, Massachusetts, a radio telescope monitoring 8 million separate radio channels has been scanning the skies for signals. This program, called META, is supported entirely by the Pasadena, California-based Planetary Society, paid for by members' contributions. A similar Planetary Society search to examine the southern skies, including the center of the Milky Way galaxy, is to be performed in Argentina. These searches are, by far, the most sophisticated ever attempted. A much more sensitive program, covering almost the entire accessible radio spectrum, is to be mustered by NASA. The search for extraterrestrial intelligence is central to our understanding of the universe and our view of ourselves. It's well worth doing. But the simple fact is that while we may consider extraterrestrial intelligence highly likely, there is as yet no evidence at all that it exists. The search continues.